Welcome to clickmyproject.com. Now we are going to discuss about the title Reliable Low Power Multiplier Design using Fixed with Replica Redundancy Block. Now we are going to discuss about the abstract of this title. The system proposes an adapting algorithmic noise tolerant architecture with the fixed width multiplier for a reliable low power multiplier design to build the reduced precision replica block RPR. In this paper, the ATN technique includes both main digital signal processor and error correction block. The proposed algorithmic noise tolerant architecture can meet the demand of high precision, low power consumption and area efficiency. Using the fixed width RPR, the computation error can be corrected with low power consumption and lower area overhead. The system takes use of partial product with analysis to find the approximate computation vector for a more precise RPR design. The proposed fixed width RPR multiplier not only performs with higher SNR but also with lower circuitry area and low power consumption. In order not to increase the critical path delay, the system restricts the computation circuit in RPR must not be located in the critical path. As a result, the system can realize the ANT design with smaller circuit area, low power consumption and lower critical supply voltage. Now we are going to see the flow of this title. The flow shows the full operation of the truncated multiplier. In this flow, the first block is main block. The main block consists of partial product generation units. So in this partial product generation, the 12-bit multiplying logic, the basic gate logics are used. Then it is first designed with 144 AND gates. Then by using the realization of gates, the partial product generation will be done to perform 24-bit multiplication logic. As the result of partial product generation, the 24-bit will be provided as 24-bit multiplier output. Then the 12 cross 12-bit multiplier provides 24-bit multiplier output combinations. Then followed to this main block, RPR block is used. RPR means reduced precision replica. So in this RPR block, truncated methodology is used. So truncated means to perform the truncation operation, the MSB part is divided into MSB and LSB parts. Then the LSB part is consist of input correction vector, main input correction vector. The LSB part is removed, it is called as truncated part. As the result of RPR block, it is in 12-bit. In the 24-bit, the truncated part considered in the series of half adders and full adders. Thus, the truncated output will be produced. Then followed to this, register elements are used to store the outputs from main block and to store the outputs from truncated block. The first register elements used to store the output from the main block, and then the second register elements used to store the output from the truncated block. Then the comparison block is used. In this comparison block, XOR logic is used to compare two inputs from two flip-flops. The first flip-flop provides 24-bit input and the other one provides 12. So the result of comparison blocks in 12-bit. Then followed to this, error correction detection will be occurred. By using this threshold logic, the error correction and detected output will be present. So finally, we synthesis and simulation the truncated multiplier result outputs. Now we are going to see simulation and implementation result of this multiplier using the Xilinx 14.2 software. In this, the VHDL language coding language is used. First, click to this truncated Xilinx ISC project. Then the software programming page will be opened. In this, the multiplier design is double clicker, the coding will be opened. In that, first we want to see the simulation result, so click to simulation, then double click to the simulate behavior model. the simulation window will be opened. In this simulation window, we have to give an input for this multiplier. Inputs as x and y, and the control is given by clock and reset. So first we are going to give the input x, first constant, give apply and then OK. Then we are going to give the input y. Now we are going to set the clock input as 0. Then we are going to first set the reset input as 1 and then run. Now we are going to give the reset as 1. Then the clock signal is given as 1. Then run. Finally, the multiplied output will be obtained as the result. Now we are going to see the implementation result. For that, first we have to click on this implementation and then right click to the synthesis XST and give run. After the synthesis XST will be run, then click. We have to see the RTL schematic diagram. So for that, we have to click this RTL schematic and run. Give OK. Double click to this IC. So this is the diagram of RTL schematic. Now we are going to see the technology schematic diagram. For that we have to click this view technology schematic and give run. Give OK. Then add create schematic. Double click to this IC. So this is the full view of the technology schematic diagram. Now we are going to see the design summary result. For that, first we have to click the implementation design, then give run all. After the implementation design will be run, then generate program file will be run. Then these all run after. Finally, the design summary will be created. Then finally we designed the fixed low power fixed with reliable multiplier design using error detection and error correction with reliable replica redundancy block is designed. Thank you.